Hello and welcome to the Preparatory workshop for the Part 3 Foundations courses. In this video I'll explain a bit how to prepare for Part 3. So if you go onto the Faculty of Mathematics website, you can find on the Prospective Students tab a section that explains precisely this. And in fact there is material for each one of the areas. In particular, for the foundations courses, the section describes in some detail what is expected of you to know before starting your courses. The good thing is that most of this content will actually be covered in these videos. So the remaining 6 videos will cover, first of all, logic-wise, they will cover the syntax and semantics of first-order logic, which you're expected to know, the completeness theorem, the compactness, and its consequences. Some consequences including things on definability and axiomatizability. What I would recommend to do would be to go through, as the website also suggests, the examples 8 to 13 from the third example sheet of logic and set theory, the Part 2 course. Once you've done those, what you could do would be to try to do the multiple choice questions, which are attached here. You can also find the answers to these. If you have any problem whatsoever with those, you can either send me an email or, of course, we'll discuss everything in the live session of the workshop. I should note here that the live session will not be recorded, and so it's an opportunity for you to express any kind of question whatsoever that you might have. So with regards to set theory, some of the things that you're expected to know and would be generally desirable to be familiar with are, first of all, the axioms of Zermelo-Fraenkel set theory. So there will be a video of that. There will be a video on the axiom of choice and a video on ordinals and cardinals. Again, as a reality check, as the website suggests, you should have a look at examples 9 and 10 on example sheet 2, example 6 on example sheet 3, and 7, 8, and 10, and 11 from example sheet 4. So these are again example sheets from the Logic and Set Theory course. You can find these on the website that I'm currently at. Again, there's a quick self-test with multiple choice questions. You can find the answers here as well. And any kind of question whatsoever that you might have, you can, once again, either send me an email or ask me in person. So finally, in terms of computability, the computability stuff is, I would say, technically it's only relevant for the model theory and non-classical logics course, but having a knowledge of some of these ideas would be good even for the set theory courses for clarifying maybe some facts, but it's generally not expected of you in any course other than model theory and non-classical logics. So again, there will be a video on computability that will be slightly more informal than the others. If you want to see things more formally, you could run through the computability section of last year's Automata and Formal Languages course notes. Otherwise, as the website recommends, there are several books that you can go through. But once again, this will only be expected for the model theory and non-classical logics course. Whereas logic, of course, you should know for all courses. Possibly, maybe it won't necessarily be a requirement for category theory. Set theory, you should definitely be on top of for large cardinals and for forcing and the continuum hypothesis. Also for model theory, there it's more of a requirement knowing what sets are and what ordinals are and cardinals are rather than knowing, say, axiomatically how all of these things come about.